Hello everyone, welcome to Numerical Methods and Integral Transform course. I am N. Praveen Kumar, working as Assistant Professor of Mathematics. In this lecture, we are going to be discuss about central differences. In the previous lectures, we discussed about forward differences and backward differences. So, when we go for basically the interpolation or differences are three categories. First one is forward differences, the second one is backward differences, the third one is central differences. So, this forward differences, to interpolate the value which is located beginning of the table, we use this forward differences concept. If that unknown value is located end of the table or end of the provided data, we go for this backward differences. If the given data are to find the unknown value which is located around middle of the table, we are going to be use this particular central differences concept. So, in the central differences, basically the two types of central differences we are going to be discuss. So, the given data is located around middle of the table, we are going to be use this central differences. So, if the located middle of the table, so we consider the nearest value, as x0. So, let us assume the nearest value may be located here, we consider x0. So, the next value we denote with positive x1, x2, so on. Just let us understand the formula. I am considering few values. So, where the previous values of this we consider with the negative signs. So, x minus 1, x minus 2. This is what the set of data of x series, and respect to y series also will be denoted with the same kind of notations. So, corresponding y value we denote with y minus 2. So, corresponding y values we denote y minus 1, y naught, y1, y2. So, we need to be construct the forward difference table with the same notation. So, we use the forward difference table. So, the forward operator, as we know, it is called delta. So, we need to be find out the differences of these two. So, difference of these two, as we discussed in the very starting session, y minus 1 minus y minus 2, which we denote with forward delta y minus 2, difference of these two. Similar way, difference of these two we denote with delta y minus 1. So, difference of these two will be denoted delta y naught, difference of these two delta y1. So, similar way we need to be find the second and third, fourth order differences. So, difference of these two will be denoted by delta square y minus 2. Difference of these two will be denoted by delta square y minus 1. Difference of these two delta square y naught. So, we continue these differences till the single value. So, it is delta cube y minus 2, difference of these two delta cube y minus 1, delta power 4, difference of these two delta power 4 y minus 2. So, this is the way we need to be construct the central differences table. So, after constructing this table, we are going to be use the two category formulas based on p factor or p value. So, which we are going to be use the forward differences operator. So, obviously, if you use the forward difference operator, the p value which we can able to evaluate using of this particular formula. So, the formula is p is equal to x minus x naught by h. So, this x is what for what value we are finding, that unknown value we consider as x. Where is x naught? What we consider the nearest value in the table. Where is that? Just I am highlighting this point. So x minus x naught by h, where h is the interval length or successive length, like, so x naught minus x minus 1, successive value difference of the x series is called h. So this is called, simply we can also call it as step size successive value difference. So we need to be find p. Based on this p value, we need to be decide whether it maybe belongs to Gauss forward interpolation formula, maybe it is related to Gauss backward formula. So these central differences introduced by Gauss. So he has introduced two different formulas. One is Gauss forward interpolation, another one is Gauss backward interpolation. Now we need to be understand when we go for this particular forward, when we go for this particular backward, we need to be understand. So based on this p value, if the p value is negative, so minus 1 to 0, if the p value is minus 1 to 0 or p value between minus 1 to 0, then we use Gauss backward interpolation formula. If the p value is lies between minus 1 and 0, then we go for Gauss backward interpolation formula. If the p value is positive, then we go for Gauss forward interpolation formula. So based on this p value, we are going to be use either forward or backward. We are going to be use the formula to evaluate the unknown value, which is located around middle of the table. So now to remember that formulas easily, by this table we can understand the formulas are very easily. Just I will be write the same table one more time. Just will be discuss how we are going to be write or remember the Gauss forward interpolation formula and as well as Gauss backward interpolation formula. So the table just one more time writing: x naught, x minus 1, x minus 2, sorry, x plus 1, x plus 2, the previous value is x minus 1, x minus 2, this is called x series values, where the respect to y series values, respect to y value is y naught, so this is y plus 1. So after these values simply positive values, before these values negative. So y minus 1, y minus 2. So in the previous slide what way we discussed, so we need to be find out the difference of these two. So therefore we will be get that respect to notations. So these notations we already discussed in the forward. So delta square, difference of these two, delta square y minus 2. So these differences better to write in the middle of this, so that will be understand easily. So delta square y minus 1, delta square y naught, delta cube. So difference of these two. So same like the previous slide, I am just rewriting delta cube y minus 2, delta cube y minus 1, delta power 4, delta power 4 y minus 2. So just I am writing the formula to remember that value easily. So Gauss forward interpolation formula. So this formula to remember easily, the formula we started with exactly at y naught. If it is forward, so if it is forward, we have to remember the formula. So if it is forward, from there one value down. So just highlight this point. Then one value up. So we need to be use this formula or these values. So one value up, then one value down, then one value up. So therefore in the forward formula it consists of these particular values. Using of these values we are going to be construct the formula easily. So either you can able to find the polynomial, just you can denote as y of x or yp. The formula starting value just we mentioned y naught. So the next value is p. Second value is delta y naught. So look at first one, second one, third, fourth, fifth, like this we need to be write. So p delta y naught, So it is a forward, just we need to be write as next term is p into p minus 1 by 2 factorial. The next term is delta square y minus 1, delta square y minus 1, then plus p into, so previously p into p minus 1, now p plus 1 we need to be increased, p plus 1 by 3 factorial, it is the third term 3 factorial. So what is the third one? Third order, delta cube y minus 1. So similar way, so previously p into p minus 1, p plus 1 is increased. So now one is negative side increment, the next one is positive side increment. So previously positive side increment, now negative side increment. So p plus 1, p minus 1, p minus 2 by 4 factorial, fourth order is delta power 4 y minus 2. So based on the number of points, so 1, 2, 3, 4, 5. So given data is having n is equal to 5 points. So we are getting the order 4. So that we are also going to be get the formula. If you have, let us assume n is equal to 6. So therefore we are going to be have one more order delta power 5. So then we are going to be get one more delta power 5 also. This is the way we need to be write or remember the formula easily. Similar way, we need to be write the Gauss backward formula. So we constructed, if it is forward, from the starting value onwards, one is down, up. Where it is a backward, so starting value, one value is up. So this is the backward. So then one value down. So one value up, then one value down. So like this easily we can remember from the table. Once you know to construct the table, from the table itself we need to remember the formula. So starting value is yp is equal to y naught. So second value is, so starting with p delta y minus 1. Then where in the forward, so negative increment first, where the backward positive increment is first. P into p plus 1 by 2 factorial, where second order is delta square y minus 1. So now previously one positive increment, now it will be negative increment. So p my negative side one value. So 3 factorial, where the formula is delta cube y minus 2. So we have one more term. So previously negative, now it is positive side increment, p plus 1, p plus 2, p minus 1 by 4 factorial delta power 4 y minus 2. So this is the way just we need to be write or remember the formulas easily by using of this particular table. So what we need to be remember basically, so if the value is located middle of the table, we need to be use the central differences based on the p value. So if the p value is negative between minus 1 to 0, so we go for, so this is minus 1 to 0, we go for Gauss backward interpolation formula. If it is positive value 0 to 1, we go for Gauss forward interpolation formula. This is the way just we need to be remember the formulas easily. Using of these formulas, we are going to be evaluate the values if the value is located around middle of the table. Thank you.